Everybody, welcome to our second round of program talks. We have a really exciting one here with Emily with Formation Bio. They spoke last year, and so great to have them back again this year. And with that, Emily, I will pass it over to you.
Thank you, Phil. Hi, everyone. My name is Emily Yates, the Associate Director of Data Management and Analytics at Formation Bio. And I'm here today to talk about getting the most out of your LLM-powered tools by focusing your attention on data structure and data context to really drive that quality. So over the last year or so, there's really been industry-changing amounts of innovation around these tools to help developers and clinical data scientists alike write more code faster and a lot more technical code too. So we have a lot of really exciting no-code solutions to build more complex applications from natural language alone. And then we also have other solutions coming from Posit that are really seriously lowering the barrier of entry to developing complex AI solutions, like LLM-powered chatbots inside of Posit applications. And this has been really exciting for me in my role, and I've spent a lot of time over the last year doing experimentation with these tools and figuring out how we can start to use them in practice. And what I found is that with this promise of, anyone can make a chatbot, comes a really natural challenge. So how do we make sure that these solutions are good in the context of clinical and pharma development? And really, I think this is a critical question that a lot of us are considering right now across industry. It's not obvious or simple. Um, so because it's so much easier for us to develop these applications, I think we can now turn our attention towards making them high quality. I also think it's important to think about, what role these chatbots are meant to occupy. And for me, I see them as making it easier to explore complicated data. And it should be just like having a clinical data expert sitting next to you and helping you sort through the data. My question here is what makes us trust a clinical data analyst on your team to perform, an analysis with the data independently and correctly in a way that we don't trust an LLM inherently? And my hypothesis here is that it has something to do with that human knowledge and that deep context that a CDA brings to the table when they perform an analysis. What's also important to recognize here is that while these new tools are really fantastic and a huge step change in industry, they're really generic tooling and they're not pharma-specific solutions. So it really turns the onus to us as industry experts to take these foundational tools and apply them in a appropriate and fit for purpose manner. So it's really that clinical expertise that we have that's transforming raw data manipulation into these more meaningful clinical insights. And so it's for that reason today that we are going to focus on this context piece, demonstrate its impact on LLM quality, and then give some practical examples of how you can increase the quality of your next AI solution. So to demonstrate the importance of this clinical context, I created this chatbot integrated with a Shiny dashboard, all using the Elmer package. The application on the surface appears pretty simple. It's taking a natural language prompt from the user. The LLM is then generating R code to visualize and filter the data. And then the output of that code is displayed through the UI of the application. And today we're going to walk through how I was able to build this application. In this case, I think it's important to understand what's happening under the hood of the simple UI design. The system prompt is going to be the most important piece of this diagram today, and it's going to be the focus of the remaining presentation. So this system prompt is set when you as the developer are creating the application, and it's used to provide a little bit additional instruction and context to the LLM to shape its responses to you to meet your particular use case. With that, the user entered query is what the user is typing into the interface to interact with the application. So that's asking questions of the data. And LLM or Elmer here is facilitating the connection to the LLM, which is the brains of the chatbot and is providing that reasoning and decision-making capability. What's really great about Elmer is that it's flexible on what provider and which model you can integrate with. So in this case, I'm using OpenAI's GPT-4o Mini. And the LLM is, in this case, essentially just a code generator. So it's generating our code as text, which is then executed by the Shiny application to filter data and create those figures in the UI. What's really important to notice about this system design is that the data that we have loaded in our R session is never interacting with the LLM. So really the brains of the chatbot has no idea what the data looks like or what the data means. And this can be really advantageous when we're thinking about working with sensitive and regulated data. But it creates, an obvious challenge for us as a developer. Because of that, it's really critical that the system prompt piece sort of pick up the slack there and contain enough information about the data and enough context about the use case that the LLM can still produce that really high quality output that we're looking for. All of this very important context that I'm talking about lives in the system prompt and is just one piece of that system prompt. So here we have a fairly basic prompt that I actually started with when I was beginning development of this application, the one we saw a few slides ago. And while it's a relatively short prompt, it really does contain all of the critical pieces of a minimally viable system prompt. First piece here we have is the role, which is setting behavioral expectations. The task provides technical specifications to ensure consistency. Constraints prevent common errors that might break a Shiny integration. And examples show the expected output structure. So this context piece is really where we're going to be focusing our iterations on throughout the presentation. Right now, it's very simple. It's just listing the two data sets, DM and AE, representing the names of the tables loaded into our environment and no additional information. We, as clinical data experts, of course, know that these two tables represent the demographics and adverse event SDTM data sets for a clinical study. But for right now, we are intentionally withholding that important information. So I want to focus on this context piece because this is where I believe the quality of the output can be made or broken. So throughout the presentation, we will sort of hold the other pieces of the prompt constant for sake of experimentation. And the idea is that with each iteration, the context will build up enough information about our data that the LLM can begin to produce clinically meaningful analysis. The additional goal here is that through this iteration exercise, it'll help us start to build an intuition to know when a system prompt might need updating and then what we can add to it to make it better. Before we get into the iteration, I want to introduce two different types of framework or of context that we can add to a system prompt to improve the quality. And these are really two things that, from my experience, can help improve the LLM as we iterate through its build. The first here is data context, which is the technical foundation. It's telling the LLM exactly how our data is structured and how it behaves. So if the LLM is generating erroneous code, the code's throwing errors, it's likely that this data context is lacking from your system prompt. And a few things you can add in this case are field level metadata, so that's specifications, data types, valid ranges, and units. Schema relationships explain how the data, how the tables connect to each other, how they join. Data dictionaries translate what might be more cryptic field names into meaningful descriptions, and missing data patterns reveal coding conventions in the data. The second type of context here is domain context. This is really the clinical intelligence layer. So it lets the LLM know what the data means in the real world. And if the LLM is returning an incorrect analysis or is misinterpreting some domain-specific terminology, then it's likely that domain context is lacking in the system prompt. Some things to consider adding in this case are semantic mapping here, which connects clinical concepts to their technical implementation. Domain ontology provides that hierarchical knowledge like MedDRA structure from system organ class down to preferred term. Subject matter expertise adds clinical significance and relevant terminology. And then concept harmonization really finds synonyms and equivalent concepts and creates language to relate those to each other. Key insight and takeaway here is that the data context ensures that the LLM's code runs correctly, And then the domain context ensures that the analysis is clinically meaningful. So really both of these pieces together are an important foundation for quality. So now we can get into the iteration. We're looking right now at the first version of the chatbot using the baseline system prompt that I showed a few slides ago. And remember that the only context provided to this is the simple names of the datasets AE and DM. So when the user is asking the chatbot to see adverse events by treatment group, simply knowing the name of the two datasets would be enough context for a seasoned clinical data analyst to be able to perform this task, quite easily. We know that to do this correctly, we need to join the two datasets together, pull in that adverse event information from AE, and then the treatment group information from demographics. So we can see that when the LLM attempted this, that the R code generated, it's not executing correctly, it's throwing an error for some reason. And we look at the R code, we see that in the absence of that proper context, that the LLM is just making up its own column names that don't actually exist in the source data. So yeah, treatment underscore group doesn't exist in AE. So because we see a issue with the mechanics of the code, it indicates an issue with the amount of data context included in the prompt. So let's look into what we could add to that system prompt to be able to fix this. So because that LLM is not aware of the right names of the columns, right names of the fields, we should add in more field level metadata and descriptions to that system prompt. We see that this can prevent LLMs from taking shots in the dark to guess those field names, and will instead, it'll be able to make more context-aware decisions when writing R code. Some types of information to consider adding here would be the field names for each variable, the data type and format. Additionally, it can be helpful to add in valid values, especially with your categorical variables. Just let it know what the different options are. Luckily, we're using really structured SDTM data, which comes along with CDISC standards. So when creating these descriptions, I was able to copy paste from the implementation guide and really didn't have to make up these descriptions myself. So now that we have a little bit more data context in there, we can see how the new and improved prompt is performing. When the user asks the same question, we are still unfortunately getting a error in the code here. So when we look closer at the R code, we see that the LLM is now using legitimate column names, but it's not realizing that ActArm doesn't exist in the AE dataset. It only exists in DM. And we would still have to join these two tables correctly to make the correct query here. So because we're still getting an issue with the code executing, we know that we need to add more data context to the system prompt. And in this case, we can look at adding more of the schema relationship. So including how the two data sets relate to each other will unlock the LLM's ability to create structurally correct data operations. And this is a really critical milestone in the complexity of the LLM. Many existing tools focus on having a single data set as source for the analysis. However, in most clinical analysis, even of reasonable complexity, we're going to need data from multiple sources. We're going to need adverse event, demographics, labs, concomitant medications, et cetera. And here we're really testing how the LLM can scale and consider more than just a single data set in its analysis, and how it can do this simply by being armed with a little bit more domain context. So before adding schema context, the LLM had no understanding of how these tables should interact with each other. Should they be merged? Are they at the same grain? So we can see that we're now adding in that critical relationship information here, giving the granularity of the table, and then the keys to join them as well. So let's see if this addition to the prompt is helping the LLM at all. So since we've given it a lot more data context, since we've started our iterations, I think we can try asking a slightly more complicated question. So let's instead ask about treatment emergent adverse events. So this column doesn't exist in either the AE or the DM datasets and requires derivation. So it's requiring another level of logistical or logical complexity from the LLM. It's really asking the LLM not simply to select existing columns, but to derive a new concept. And when looking at the our code, we can see that the LLM has made an incorrect assumption here that adverse events and treatment emergent adverse events are the same thing when we know that that's not true. So now we see that the code generated is executing correctly. So there's no errors, there's no technical issues. It's just the LLM didn't quite understand what we were asking for in the context of a clinical analysis. So for that reason, we can move past data context and focus on adding domain context now to the system prompt. So before adding in that domain context, even with sufficient amounts of data context to get correctly executing code, the LLM is really just operating as a generic data analyst. So sure, it can join tables correctly, it can handle data types appropriately, but it's really lacking that clinical intelligence to really analyze the data. Adding in that domain context really aims to equip the LLM with that specialty clinical trial expertise and the flexibility to answer a wider range of user queries. Things to think about adding here are definitions of any terms that might be related to the analysis. So, for example, I included the definition of a treatment emergent adverse event here. I'm also including the shorthand for the concept. And really importantly, I'm tying that clinical concept to its technical implementation. With a more trial-specific solution, you could think about including things from the study design that could influence the analysis, like schedule of events and visit window, endpoint information, and things like that. So let's see how the prompt is performing now with the inclusion of domain context. We see now that when we ask about treatment emergent adverse events, the R code is recognizing that this concept doesn't already exist in the data, and it's attempting to drive a new column, which is great. Even better, it is actually correctly reflecting that treatment emergent adverse event. So it's driving it correctly here as well. So with this, the LLM is showing signs that it's graduating from general data analyst to clinical data analyst. And one way that we can pressure test the LLM's knowledge is by changing the phrasing of the question ever so slightly and seeing how consistent the LLM's output is. So being able to return consistent results with inconsistent prompting is really critical for a deployed application with many different types of users. Think about how a statistician versus a clinician or a novice versus experienced prompter might ask questions of the LLM slightly differently. And it's important that the LLM, number one, recognizes that these different phrases are, in fact, the same core question. And then number two, return consistent results. So if this is working well, the user doesn't need to learn a quote unquote magic phrase to get the right analysis. And we can see that with sufficient domain context built up, especially with that semantic data mapping, that the LLM does a pretty good job of figuring that out. So with that, I'll leave you with a couple key takeaways from what we've talked about today. First, clinical data analysis is the summation of data plus that human clinical knowledge. So this human expertise is really what's transforming simple data manipulation into more meaningful analysis. Second, the lesson LLM has to guess the higher quality output we'll have. So in the absence of context, an LLM will resort to guessing. So really with each additional piece of context that we're giving it, we're replacing guesswork with precision. And third is to iterate and test your system prompts. System prompts are really critical for these quality AI systems. My advice is to start basic, start with data context, and then layer in that domain expertise. Think about including edge cases and how different users might interact with your app differently.